Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is product sum arrays. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an integer n and array A is called good if it follows the following condition. That is, all the elements in the array are greater than equal to 1 and less than equal to n. The number at ith index is less than or equal to I plus 1 index. Then sum of all the elements is equal to n as well as the product of all the numbers is equal to n. In other words, the array should consist of non-decreasing positive integers and its product and sum must be equal to n. Here, this represents the length of A. Now, let R denote the number of good arrays, and our task is to find the value of minimum between R and 3. That is, we should be able to determine whether the value of R is 0, 1, 2, or greater than equal to 3. Let's see the input format. For each test case, we are given a single line that will contain the integer n. As for the output format, we simply have to output the value of minimum of R and 3. For the constraints, number of test cases will go from 1 to 20 and value of n will go from 1 to 10 raised to 9. Let's see some sample inputs. So for the first sample input, the value of n is equal to 1 and there is only single array that we can have, that is just 1. Here, the sum is also 1 and the product is also 1. If we increase it any more, let's say we make it something like this, then even though the product is still 1, the sum becomes 2. And as we have seen the condition, the product and sum of all the numbers has to be equal. So there is only one such good array. Similar cases can be found for 2 and 3. Let's see what happens when we have n as equal to 4. When we have n equal to 4, there are the things that we can do. The first array can be 4 itself. Always, the product and sum are the same number. The other is we can have 2 comma 2. Here, the sum is also 4 and the product is also 4, while all the numbers being less than equal to 4 and these are in the previous number is always less than or equal to the next number. So we have two such arrays here. Therefore, the answer here is also 2. Let's see how we can approach the solution. As we have seen, when a number n is given to us, all the elements that has to be present in the array for it to be make sure that the product is equal to n, it means that all the numbers involved must be factors of n. Now as we have seen, since these numbers multiply or product and give us n, it means that their sum must be less than or equal to the product itself. Now in this case, what do we do to make sure that our sum and our product are equal? Well, there's a number that we can use, that is 1. When added, it does not affect our multiplication, so our factors will remain intact even if we add multiple times 1. But to make sure that our sum is also equal to n, we can keep on adding ones until it becomes equal to n. So for this, what we are going to do is, for a number n, we'll find all the factorials. So in this case, as we have seen, it is a, b and c. The first array that we can make would be ABC, that is multiple of all the numbers. This will be the number itself. Next we can make A, B and C. Similarly, we can make A and B into C. And finally, we can also make A, comma B, comma C, right? All these with product will give us the number n. And to make sure that their sum also gives us n, we can simply keep on adding bunch of ones as required. Now our goal is to find the minimum value of r, comma 3, where our r is a number of such good arrays that we can form. So for this, what we need to find out is whether r is equal to 0, 1, 2 or greater than equal to 3. Now in this case, if the number of prime factors that we have found, if they are equal to 1, that is it's a prime number itself, the answer will always be 1. If it's 2, the answer will be 2. But if it's anything greater than this, the answer will always be 3. So this is how it will go. We'll find all the count of prime factors right? If it is less than or equal to 1, the answer is 1. If it is equal to 2, well, there goes our answer, it will be 2. But if it is greater than or equal to 3, then our answer would be 3 as per the equation given to us here. So with this, we find the prime factors and get a solution. Let's see how we can implement this solution in C++. So for each test case, we call the function solve. We take the input of n, then we find out the total number of prime factorials in our number n. So what we do is, we go over all the values of I that are greater than equal to 2, but less than the square root of our number. It can be less than or equal to. Then we keep on dividing n with I if it's divisible, and those will be our prime factors. Once we have this count, at the end the number itself can also be in our array. So we check that in case our n is still greater than 1, we will add it to our count as well. Now at the end, if it's less than or equal to 1, as you saw, our answer would be 1. So for that, we use this equation of max of 1 comma prime count. It will make sure that we never get 0. Now, once we have done this, as you have seen, if it's 2, our answer is 2. But if it's anything more than that, if it is 3 or more than that, our answer would be 3. So then we simply get the minimum of whatever value we have here and 3. And with this, we'll know whether our answer is 1, 2, or 3. And as you can see, I've got an EC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, and then count the prime factors in our number. We check what is the maximum between 1 and the prime factors that we have. Whatever is the result, we take its minimum with 3, and that we print as our answer. As you can see, I have EC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.